The earliest known enameled pieces have been dated to the 13th century BC, when Mycenaean goldsmiths inlaid enamels into gold rings. Since then, cultures all over the world have incorporated enameling into their art forms. In the 5th century BC, Greek artisans used enamel to decorate artworks such as the Phidias statues of Zeus. Champleve, French for raised field or raised plain, is a technique in which enamel is inlaid into troughs or depressions that are carved, etched, die struck, or cast into the surface of a metal object while leaving the surrounding metal exposed. The piece is then fired until the enamel fuses to it, and when cooled, the surface of that object is then polished. The uncarved portions of the original surface remain visible to frame the enamel designs. In most medieval works, polished metal is then typically gilded. Champleve differs from the more common technique of cloisonné enameling, in which the troughs are created by soldering flat metal strips to the surface of the object before being inlaid with enamels. Champleve has been used since ancient times. Consistent and frequent use of Champleve is first seen in the Latin style of early Celtic art in Europe. From the 3rd century BC, where the predominant color was a red enamel on a base metal of bronze. However, this was technically not true enamel in the usual sense of the word, as the glass was only heated until it became a soft paste before it was pushed into place on the workpiece. This is sometimes informally known as a sealing wax enamel, or described as glass inlay. True enameling techniques learned from the Byzantine Romans is where a powdered glass is used to fill those depressions of the metal. The work is then fired until the glass liquefies and fuses. In Romanesque art, from the middle of the 12th century to the middle of the 14th century, the potential of Champleve was more fully realized. Decorated caskets, plaques, and vessels were produced in Limoges in France, and the Meuse Valley in Belgium, and also in Spain. Works from the Meuse Valley were sometimes gold or made of gilt silver, but in Limoges in Spain, those Champleve works were usually copper that were gilded in gold. In Limoges, at the very beginning of the 13th century, the lands were owned by the Plantagenets. There, the Duke of Aquitaine expanded the distribution of Champleve works produced in that region. As a result, the Pope himself came from Rome to buy Limoges Champleve objects to equip Rome's churches with altar items and reliquary caskets. In this video, I will demonstrate the process of creating a Champleve medallion. I typically begin by creating a vector graphic of the design that I want in a program such as Inkscape. I prefer using a vector graphic because the image is easily edited or modified and is infinitely scalable without any loss of detail. In order to create the resist for etching the medallion, I will print the design onto a special transfer sheet using a laser printer. Once printed, I'll be able to transfer the design onto the workpiece by using a hot iron to essentially iron it on. Note that this process requires a laser printer or copier that uses powdered toner. An inkjet printer will not work with this product. Starting with a piece of 16 gauge sheet copper, I'm going to use some acetone to wipe it down, clean it off, to remove any dirt, oils, grime, grease, anything that might contaminate it and prevent the resist from sticking to it. Here I'm applying some packing tape to the backside of the workpiece. This prevents the ferric chloride from etching away the backside of the medallion and making it thinner than I really want to. The key here is to use a good quality masking tape or packing tape that's waterproof, that's won't let the acid or the etchant get to the copper, and is relatively easy to remove afterwards. I'll use a brayer here to make sure that it's laid down flat and there's no bubbles underneath it, and then I'll cut the excess off. Here we're going to use an iron to essentially iron the design, the resist, onto the copper itself. So we've cut the transfer sheet out. I'm going to place it onto the workpiece. I'm going to cover it with a piece of paper because that makes the iron slide over it and not catch onto the mylar backing. The important part here is that we set the iron to its highest setting. We're going to set it to its wool or linen setting, and we want to heat the copper up to a high temperature so that the toner that is on the transfer sheet melts onto the copper and transfers over, and that becomes the resist for the etch. So we're going to make sure it's hot. I'm going to use a brayer to roll it out and try to make sure there are no air bubbles in. Then we're going to take a look at it, actually heat it up a little bit more. We'll pull the paper off and take a look at it, and it should look like the transfer is all the way through the plastic. After letting the piece cool to room temperature, I'll carefully peel back the mylar sheet from the transfer, and it reveals the resist for the etch. Here I'm going to prepare my mordant and etch it first by putting half a beaker, 50% of the beaker full of distilled water. Always start with the water, add your acid to the water, and then I will add the rest of it is going to be 50% ferric chloride. Easily obtained, relatively controllable, reasonably safe, but it stains a lot. So we'll fill the beaker the rest of the way up with that, and we should be almost ready to etch at this point. The last thing we need to do before etching is to put the workpiece into a little cradle. And then we're going to lower it into the ferric chloride and water. And we'll turn on a little air so that it bubbles. And the bubbling will help to agitate the etchant and will help to make sure that the dross falls out of the etch and you get a nice smooth finish in the background. Every 15 minutes or so, we're going to remove the piece from the etchant. We're going to take a little distilled water and we're going to squirt it down, sort of rinse it off. Then I'm going to take the piece and I'm going to rotate it anywhere from 90 to 180 degrees, either on its side or upside down, and then it goes right back in the bath. After about an hour and a half in total of etching time, I'll pull it out, give it a final rinse. Sorry, you can't see that. And when I decide that the etch is deep enough without being too deep, then I'll just remove the piece from the etchant. We'll neutralize it in a neutralizing bath, and the etch is done. After we've neutralized the etchant, we're going to clean the resist off with a little acetone on a rag, and it's just going to wipe the resist right off of it. And we get a really good look at the final etch. Now we'll go ahead and take the tape off of the back so we no longer need that resist. And if you use good quality tape, it comes all off in one piece. Once the resist has been removed, I'll take this to the bandsaw and we'll cut the medallion loose from all the rest of the copper. Ultimately, I'll cut as close to the medallion as I possibly can. When I'm done with this, I'll take a selection of hand files, file off and the remaining saw marks, smooth all of the edges, and make it ready for receiving the enamel. Now that the medallion is etched and we have our raised fields, uh, it's time to prepare the enamel that we're going to pack into those fields so that we can fuse it in the kiln. So we start with a powdered enamel, which is essentially powdered glass, powdered colored glass. We need to wash it. So I'm going to drizzle some water in and we'll swirl that around. Most of the impurities will start to float off and we'll pour that off, leaving glass behind. And we'll do this a couple of times till what I pour off is essentially clear, or as clear as possible. And at that point, it'll be ready to bring over to my desk for a technique we call wet packing, where we'll take the wet or damp glass powder and pack it into those compartments that we just etched out of the medallion piece. Once the glass is relatively clean, we bring it back. We add a binder. In this case, it's called Clearfire, which helps the enamel powder stick to itself once it dries out. Um, and we begin to use that, moistened with the binder, to essentially paint or wet pack the compartments that we etched out. In this case, I'm using a brush to pick up little globs of the enamel and place it where I want it. Um, Typically, one would start with the darkest colors first, but that would be depending on the way the piece is laid out. The binder itself, again, is there to prevent the glass from flaking off once the enamel has dried. You must dry the enamel before um, putting it into the kiln, because if there's moisture in it, it'll create steam and it'll pop off, it'll flake off, it might even explode a little bit. So here we're starting with the next color, a little bit of white into some very small compartments. Again, uh, it all depends on how the colors are laid out. Uh, it's to the best order to put it, but typically you want to start with darker colors first. As I mentioned before, I'm using a brush to do the wet packing here, but in period, they would have used a feather, a goose quill that had been carved down to make a little scoop. They may have used some brushes, some more, again, some feather brushes to get that enamel powder placed exactly where they wanted to. I myself, I have some paddle scoops to pretty much do the same thing, but I find I have more control using a brush. So here we are, putting the last color down. I've already filled in the field full of black. Now I'm filling the wings with some gold yellow. The trick here is to overfill the compartments, at least on the first, before the first firing. That's going to mean less work in the future. So placing the enamel here, placing enamel into these compartments. Once the piece is dry, it goes into a 1475 Fahrenheit kiln for about a minute and a half. Once it comes out, we set it on someplace heatproof and we let it cool down to room temperature. Once cooled, we'll put it into a pickle, which will essentially dissolve all of the black oxides that form on the piece in the kiln, and it will brighten the piece up, make it nice and coppery. After the pickle, you'll see the bright copper and the lumpy glass that's going to get ground down later. Before anything gets ground down, I'm going to apply a coat of glass on the backside of the medallion called a counter enamel. When the glass is heated and it cools, it stretches and pulls and pushes at the copper, so the counter enamel on the backside helps to equalize those stresses on the medallion. I typically like to use a clear coat, we call a flux, on the backside. I just like to see the copper come through kind of brightly. Because I'm coating the entire medallion, I don't need to wet pack it. I can simply sift it on dry, and then it gets put in the kiln as is. So with the dry sifted counter enamel, it goes back into the kiln for a minute and a half and right back out. Get a look at it real quick and we'll set it out to cool. Now it's time to grind the glass of the front side smooth. I'm going to be using a diamond abrasive pad and some water in period, and I've used this before. They would have used a set of essentially stones, carborundum stones or alundum stones, as they're called nowadays, different compositions. And essentially, you're going to grind away at the top of the piece, smoothing the glass out, exposing all of the copper fields that are supposed to show through the glass. And when you're done, you'll dry it off and see where you need to add more glass. This is what the piece looks like after the first firing and after the first grinding. You can see the shiny spots. Those are the areas where there wasn't enough glass and we have to add some. So I'm going to start wet packing again, starting with the white, because there's only a little small area that needed some extra glass. I'll change to another color, start doing the yellow in the wings. I'm using the light and the reflection of the light, looking for reflections and voids, looking for any place that did not get ground down. Anything that's dull and looks kind of scratchy is someplace that was adequately ground down. The important thing is that you can see all of the copper traces from the design that show through the glass. And it's okay at this point that I'm going to go ahead and overpack these places again, because once again, after firing, it's all going to get ground down again. And now I'm going to start filling the last parts of the black. Just a few of those voids. They'll look shiny while they're wet, but they'll get filled, and then we get ready to fire the place one more time. Once again, it goes back into the kiln. We wait another minute and a half, and it comes right back out. Cool. I'll go through the grinding process one more time, seeing that there's very, very few voids left. I will just put it back into the kiln one more time, and what will happen is this is just to make the ground glass smooth. When it comes out in a minute and a half, it's going to be nice and shiny. Not shown here is the part where we take the medallion after the last firing and we polish all of the copper to a mirror finish. Uh, at this point, we're going to begin the plating process. Uh, we're going to start by plating the medallion in nickel. The nickel gives a bright base for the gold to lay on top of. It strengthens the copper. Uh, the electroplating process is also much safer than the period gilding process, which was essentially amalgamating gold into some mercury, painting that mercury onto the piece, then burning the mercury off, heating the piece till the mercury burned off and fumed off, leaving the gold behind, and effectively gilding the piece. So we're trying to do this in a safer manner, create it nice and shiny with uh, nickel first, and then we'll continue with gold. Again, unlike the fire gilding process, I'm using an electroplating process to deposit gold on the outside of the medallion, any exposed metal. Specifically, I'm using a process called brush plating. It's very economical. It doesn't use a whole lot of gold, but I still get an 18 karat finish, and I only deposit the gold where I need it, and I don't have any waste from tubs and tubs of solution to dip things in. So, power supply, a brush, and a couple extra wires, run 2 volts through it, and we can deposit gold on the outside of the medallion. And a look at the finished piece. It's gold, it's shiny, it's pretty. I hope you enjoyed the video. Thanks.